Psst. Xenon,
Yes, Ruthenium?
how come the nickel twins don't look like twins?
Well, not all twins look exactly alike.
Well, they look a lot alike, but one is fat and one is skinny.
That just means they're different isotopes. They're exactly alike otherwise.
Oh, Xenon, there you go with your big words again.
Well, I just happened to be reading about this topic. Let me show you. This chapter is all about the mass of oxygen. A typical oxygen atom has an inner nucleus of 8 neutrons bonded to 8 protons, and orbiting the nucleus, a small shell of 2 electrons, and beyond that, a second shell of 6 more orbiting electrons. So, we have a total of 8 protons, 8 neutrons, and 8 electrons in one oxygen atom.
Yeah, whatever, Xenon. I didn't ask about oxygen. I was asking about the nickel twins.
We'll get there, Ruth. Now, electrons, of course, have almost no mass, but each proton and each neutron contribute about 1 atomic mass unit each, giving the oxygen atom a total mass of 16 AMUs.
Again, that does not look like nickel.
Patience, Ruth. At any rate, oxygen's atomic number is 8, and we get that atomic number from the number of protons. Atomic mass is always written as a whole number, followed by a decimal number, but atomic number is always written as one whole number, no decimals.
You do realize that's the world's most boringest book ever. I think I need a nap now.
Ruth, the next chapter gets more interesting.
There's that big word again.
Correct. Anyhow, oxygen typically doesn't form isotopes, but many atoms do. An isotope just means that particular atoms from the same element have the same atomic number, which means the same number of protons, but they have differing numbers of neutrons. Since neutrons are important when determining atomic mass, the mass of isotopes can vary.
Ooh, it's one of the nickel twins. They're famous. So, nickel's atomic number is 58.69?
No, Ruth. Recall that atomic mass is written as decimals on the periodic table. The average mass of nickel is 58.69 AMUs. Atomic numbers are always written as whole numbers.
Oh, I get it. Nickel's atomic number is 28, and that means 28 protons in each nickel atom. Right?
Goodness, Ruth, maybe you are paying attention. If we round the mass off to 59, we can do some math.
Some math?
Yes, we'll subtract 28 from 59. 59 minus 28 equals
31. I know my 2-digit math.
Very good, Ruth. So, on average, nickel atoms each have 31 neutrons. But unlike most oxygen atoms, nickel can form isotopes. Nickel 58, for example, has 58 minus 28, or 30 neutrons. Nickel 64 has 36 neutrons, and so on.
And that would be the fat nickel twin.
We'd have to put him on a scale to know for sure, or just count his neutrons.
Hey, nickel twins. Xenon told me all your secrets. Hey guys, look, it's our friend Xenon.
Hi, Ruthenium, uranium, and, your many, many friends.
Yeah, I'm popular. Say, Xenon, why you being such a downer and hanging out all alone when there's a party going on at the picnic tables?
Well, I like my me time, and I love to read.
Oh, a book? I've heard of those. What makes it so much better than hanging with your friends, Xenon?
Let me see that thing. Fascinating Secrets of the Periodic Table. Holy cow, Hydrogen, you're in here.
Yeah, well, I'm number 1 on the periodic table, so it makes sense someone would write a book about me.
Hey, wait a minute. It's not just you, Hydro. Sodium is in here. And calcium. And aluminum. And all my best buds. And whoa, even me, I'm famous.
Not me.
Yeah, at the end, like a footnote, 'cause you're not very important.
That book sounds like a spy novel. She's spying on us.
No, it's just I'm a group 8A element, which makes me kind of a loner.
Yeah, we love you, Xenon, but you've always been a little aloof.
I have a 4-valence shell, 8 electrons. There's no room for more, so I typically don't bond to form compounds or molecules.
What you talking about, loner chick? What are valence electrons?
Hydro, it makes sense you don't know that because hydrogen has only 1 electron. That's it. No inner electrons, so since valence electrons are outer electrons, your one and only electron is your valence electron. But you're a rule breaker, Hydro. All other elements in group 1A of the periodic table have only 1 valence electron as well, but they also have inner electron shells, and unlike you, a gas, the others are all highly reactive, sometimes volatile, alkali metals.
Like sodium over there, that crazy dude can't even get the letters on his belly right.
Well, sodium's atomic symbol is Na. It's a Latin-based symbol, which may not make sense to those of us who speak English, but
He doesn't really speak much of anything.
I'm confused, Xenon. I don't see any shells on sodium.
Yuri, shells are layers of electrons. Sodium is atomic number 11, which means he has 11 electrons total. 2 of those are in his inner shell, sometimes called an orbital. Sodium's next 8 electrons are in his second orbital, but he's a period 3 element, so, like hydrogen, he has 1 valence electron but a different period.
Period?
Here's our friend calcium, a group 2A, period 4 metal. As you can see, she's in the second column or group of the periodic table, which means she has 2 valence electrons, and she's 4 periods down. The first 3 periods mean she has 3 inner electron shells. Like all of us, except our rule breaker friend Hydro, she has a small inner shell where 2 electrons orbit, 2 shells with 8 electrons each, and then her 4th shell holds her 2 valence electrons. By the way, Group 2 comprises the alkaline earth metals, also sometimes volatile, but not as much as Group 1.
Yeah, Cal, you are a little moody.
So, I'm in row 3.
Period 3, aluminum, yes.
And column 3, group 3A, so that means I have 3 shells total. And the third one, the outer orbital, has 3 electrons?
That's correct. But be careful. Some versions of the periodic table refer to your group as 13. In this case, we subtract 10 to get the number of valence electrons. Carbon here, for example, is in group 4A, also known as group 14. Either way, I have 4 valence electrons. That's right, carbon. And nitrogen has 5 valence electrons, and so on. I'm here in group 8A, also known as group 18, the noble inert gases.
Inert means you're a loner chick, right?
Right. The number of valence electrons explains how atomic bonds are formed, and group 8A doesn't form bonds. That's in the sequel to this book.
Xenon, where am I in your book?
You're down here, uranium, toward the bottom. You share similarities with these elements in the middle, but you have some unusual properties. So you're pulled out of the periodic table and placed in a separate category with the lanthanides and radioactive actinides. Together, you comprise the F block.
Where am I? And how many valence electrons do I have?
Ruthenium, you're here in the D block. And, like your brother, you are transition metal. Those of you in the D block are rebels. You don't follow the octet rule.
Yeah, rebels.
What's the octet rule?
The rule of 8. With most elements, the maximum number of valence electrons is 8. But with transition elements, they don't always follow the rules. Anyhow, our first two groups form the S block, and over here is our P block. Most elements on the periodic table are metals and solid at room temperature, but a few of our friends here, like oxygen, nitrogen, and chlorine, are gases at room temperature, although there are some metals in the P block, like our friend aluminum, and some metalloids like silicon. Most on the right side of this staircase are gases.
So, Xenon, tell us more about the octet rule and what it explains about how we bond to form molecules, and why you don't.
Sometimes, Ruthenium, you just need to save a few plot twists for the sequel. Now, why don't all of you skedaddle and let me finish my book?
Let's go back to the party. Bye, Xenon.
Okay, bye.
See you later.
Bye, Xenon.
Bye,
Toodaloo.
Xenon.
Goodbye, Xenon.
Okay.
Enjoy your
Bye,
book.
catch you later. So long.
So long.
Xenon, I can't believe what a party pooper you are.
The party's been going for a couple of hours now, and you're still reading that spy novel?
It's not a spy novel, but I finished it, and now I'm reading the sequel, and now all of you are back to...
Trying to get you to join the fun.
Yeah, Xenon, we love you. And we just want you to quit being such a loner and have a good time with us.
Love? Look, Ruthenium, I'm fond of you and Yori and your friends, but I don't really love or bond with anyone. I told you, I have 8 electrons in my valence shell. I'm an inert, noble gas with a full octet. There's no room here for bonding.
I don't mean love, like me and my boyfriend Hydro here.
Whoa, slow down there, Ruthie. We just met a couple of hours ago. I bond with lots of atoms. Me and my twin brother bond with oxygen over here when we make water. Me and my brothers and carbon here make beautiful explosive methane and other fuels together.
According to this book, Hydrogen, that's absolutely correct. Because you have one valence electron, you can bond with almost any atom, except me and my other noble gas cousins. You can form covalent bonds with nonmetals to create gases, liquids, even acids. And you can join with metals to create ionic bonds of solids, liquids, even bases, which are the opposite of acids.
You're fickle, Hydro.
No, ma'am. I'm versatile. Yeah, me and chlorine sometimes hang out to form hydrochloric acid, and sometimes me and sodium and oxygen get together to form the base sodium hydroxide.
Yep. And sometimes I get together with Hydro and 2 of his brothers, and we form aluminum hydride.
Yeah, well, you made your point. You sure get around, Hydro.
Other than we inert gases, most atoms do, Ruthenium. Atoms can be recycled infinite times, breaking bonds with one molecule and forming new bonds with others. It happens every time there's a chemical reaction. Here on our planet, chemical bonds are most common with elements on the top half of the periodic table. Carbon, silicon, aluminum, calcium, oxygen, sodium, iron, nitrogen, and a few others.
What about me and my sister Ruth?
You're further down the periodic table and more rare, but that doesn't mean you can't form minerals and other compounds. Ruth and the chlorine triplets can form ruthenium chloride, for example.
Say, Xenon, what were those big words you used? Ionic and covalent?
Good question, Hydrogen. Ionic bonds are formed between two or more ions, which, of course, are charged particles created by an imbalance of protons to electrons. Within the bond, there will always be at least one cation. Cations are positively charged metals, often from groups 1 and 2 of the periodic table. In ionic bonds, cations bond with anions, which are negatively charged nonmetals from the upper right side of the periodic table.
Plus me over here. I'm a rebel who doesn't follow rules.
That's right, Hydro. You're the only nonmetal on the left side of the periodic table. Now, in an ionic bond, the metal transfers its valence electrons to the nonmetal in order for both atoms to stabilize and form full octets of 8 electrons. The most famous example of this is table salt, or sodium chloride. Sodium is here in group 1A, which means he has one valence electron, which makes him a little imbalanced. But chlorine in group 7A has 7 valence electrons, and she will stabilize into a full octet as soon as she acquires one more. Once sodium gives her his valence electron, he stabilizes because his lower orbital shell already has 8 valence electrons.
So after that, our wild and crazy sodium friend will turn nice and mellow, like you, Xenon.
Oh, that's sweet, Yori. Anyhow, Hydro, covalent bonds are formed between two or more nonmetals, like when you and oxygen make water. The difference is that you share your electrons, like two people sharing music with the same pair of earbuds.
You crack me up, Xenon. Everyone knows people are a myth.
Except elves. Elf people are real.
Now, with water, H2O, we of course have 2 single-electron hydrogen atoms bonding with one 6-valence electron oxygen atom, therefore fulfilling the octet rule. But unlike ionic molecules, since covalently bonded atoms share their electrons, they can sometimes form double or triple bonds between atoms. This means covalently bonded molecules sometimes fulfill the octet rule in creative ways, and they don't always have a total number of electrons that equal multiples of 8.
I'm a metal. What if I bond with other metals, like silver or gold?
That would make you a metallically bonded alloy. Electrons move about freely in metallic bonds and don't stick to just 1 or 2 atoms. That's why we use metal wires in our light fixtures and other electronics. Free electron movement causes electric currents.
So, covalent, ionic, and metallic, those are the only types of atomic bonds?
Those are the most common kinds.
What about the bonds of friendship?
That's too close, Ruth. I have a full octet. I don't have room in my life for any bonds.
Come on, Xenon. You know you love us. Group hug, everyone.
No means no. I don't.
Say you love us, Xenon. Say it.
If I say it, will you all give me my space?
Sorry, Xenon. We don't want to freak you out. We love you. You can come down now.
Okay, I love you. All of you.
Wow, Xenon, you're usually so mellow, and I've never seen you show so much emotion.
It does seem I am capable of fear and disgust.
Love is an emotion.
Love is a decision one makes to express preferential fondness toward others, not an emotion.
You said you love us, and love is an emotion.
The same way that sarcasm is an emotion, I suppose.
Xenon, why don't you come join us at the party?
I prefer my own company, but thank you. Never mind. I'll go. Just keep a polite social distance, please. Folks, this is Carbon. And this is Xenon. And we'd like y'all to hit like, subscribe, and that little bell thingy. Oh, and please consider supporting Xenon and Friends at patreon.com.